Every time you accidentally swallow seawater, that sharp, salty taste hits instantly. But here's something strange. What you're tasting isn't just salt. It's billions of years of Earth's history, and the real mystery is this. The ocean should have become extremely salty over time. So why didn't it? Think about it. 1 liter of seawater contains about 35 grams of dissolved salts, while freshwater has less than 1 gram. And if you could remove all the salt from the oceans and spread it across land, it would cover entire continents in a layer hundreds of feet thick, almost like turning Earth's surface into a massive salt desert. So where did all of this salt actually come from? To answer that, we need to go back nearly 4 billion years to a time when Earth had no oceans at all, just a hot, violent surface covered in erupting volcanoes, constantly releasing gases into the atmosphere. These volcanoes didn't just release lava, they released huge amounts of water vapor, along with gases containing chlorine and sulfur. And as the planet slowly cooled, that water vapor condensed into clouds, leading to intense rainfall that lasted for millions of years. But this wasn't normal rain. As it fell through the atmosphere, it mixed with those gases and became slightly acidic, and when it hit the rocky surface of early Earth, it began breaking those rocks down, slowly dissolving minerals like sodium, calcium, potassium, and magnesium. Now here's where the story takes a turn. That rainwater didn't just stay where it fell, it began flowing, forming streams and rivers, carrying all those dissolved minerals across the land and into the newly formed oceans, while at the same time, chlorine from volcanic gases had already mixed into the water. And when sodium from rocks met chlorine in the ocean, they combined to form sodium chloride, the same salt you use in your food. But the ocean isn't just filled with table salt, it's actually a mixture of many dissolved minerals. Although sodium chloride makes up the majority, around 85% of all dissolved salts, turning the ocean into something like a giant, ever-changing mineral soup. Now here's the part that confuses most people. If rivers have been carrying minerals into the oceans for millions of years, and ocean water keeps evaporating, leaving the salt behind, then logically, the oceans should keep getting saltier and saltier. Right? But they don't. And this is where things get really interesting. Because while salts are constantly entering the oceans, they are also being removed at almost the same rate, creating a natural balance that has kept ocean salinity surprisingly stable for millions of years. For example, some of these minerals don't stay dissolved forever. Marine organisms actually use them. Calcium is taken by corals and shellfish to build their shells and skeletons, locking it away from the water. Other elements, like potassium, get trapped in sediments on the ocean floor, especially in clay, while some sodium and other ions are absorbed into the ocean crust through reactions with underwater volcanic rocks, especially in deep-sea regions where hot water interacts with the seafloor. And there's another hidden process most people never think about. Sometimes seawater gets trapped in isolated basins, and when that water completely evaporates, it leaves behind thick layers of solid salt. These deposits have been forming for hundreds of millions of years, quietly removing salt from the oceans. So even though water keeps evaporating and leaving salt behind, these processes are constantly pulling salt out, almost like the ocean has its own built-in balancing system. And that's why, despite billions of tons of minerals entering the oceans every year, the average salinity stays around 35 grams per liter. But here's something even more fascinating. The ocean isn't equally salty everywhere. In places where heavy rain falls or large rivers flow in, the water becomes less salty, while in hot regions with high evaporation, salinity increases. Ocean currents then move this water around the planet, redistributing both heat and salt, creating a global circulation system that helps maintain this delicate balance. So the next time you taste seawater, you're not just tasting salt. You're experiencing a story that began with volcanoes, continued through rain and rivers, and is still being shaped by life and deep ocean chemistry today. And here's the thought that should stay with you. The ocean's saltiness isn't random, it's perfectly balanced. And if that balance were to shift even slightly, it could affect marine life, ocean circulation, and even Earth's climate. A simple sip of seawater carries the weight of an entire planet's history, still in balance, still in motion, and still holding secrets we haven't fully uncovered. Can you tell which is the purest form of natural water? Comment your answer.